Hi friend, have you ever wondered how big companies analyze their massive amounts of data? They use SQL and so can you. In this video, I will show you on a simple 5-row dataset how to apply the basics of SQL. We will be querying data, we will be filtering data, we will be grouping our data, and finally aggregating data to see, for example, average salaries of employees. As a first step, let's have a look at the data that we are dealing with. And we do this by selecting our data. Select, then we will add an asterisk which says all columns. So select all columns from the table employee. That's the one that I have prepared here. And then I hit execute, and there we already ran our first SQL query. We retrieved our 5-row dataset with 6 columns of data. I will put the data up in the corner so you can always follow along what we are selecting. Let's say we are only interested in 2 of those 6 columns, and then we can mention them by name. So we can say, for example, we want the first name and we want the salary column. If I execute it, fair enough, I just get those 2 columns. As you might have realized, I put hard brackets around the first name. This is to tell SQL that this is a column name. Otherwise, it would try to stop it at the space in between. Now, let's put in sort order to our query. And this is done with an order by in SQL. Order by, and now I can select one of those columns. Let's say we want to order it by our first name column. I would edit here, and then I can say ASC for ascending order. Hit execute. And fair enough, the B first in the alphabet, the Ben comes first. As you might have guessed, if I can say ASC, I can also say DSC for descending. And then the order is switched around. Next up, we can use case when statements to classify our data. So let's say we are interested in our first name and salary range. So I say case when salary is bigger or equal to 80,000, then let's call it high salary. Otherwise, in the else case, it's a normal salary. And then we end this case when statement, and you see here I added them in single quotes. This is how we tell SQL that there's a text following. Let's run this. And we see John and one of the 2 Bens have a high salary, the other 3 have a normal salary. As this is a calculated column now, we don't have a column name that comes from the system, but we can give it one by saying as salary bucket, for example, whatever we want to call it. If I execute this, there we have our column name. Now let's say we are interested only in a subset of the data. This is where filtering with a where clause comes into play. The where always is coming after the from. So we have a where salary is bigger or equal to, now I can say whatever I want, but let's say 80,000. And if I run this, I only have John and Ben left, those with a high salary. Let's just show their salary as well. If I execute this, there we see it. Okay, one of them has 80,000, the other one 100,000. Let's now say we are interested in employees that are somewhere in between. So we can say where salary between 60,000 and 80,000. Let's run this. There we see, okay, now we have a John, an Ed, and the Ben with a normal salary. And you see that the 80,000 is included. So the between is up and including 80,000. The next thing we might want to do is filter by text instead of by numbers. And we can also do that in SQL in the where clause. So let's say where the first name is equal to Ben. running this, we see, okay, we have 2 bands. But the beauty comes when we search for wildcards. So everything that matches a specific pattern we can search. We can say where the first name is like percentage n. Percentage in this case means an arbitrary number of characters is here in the beginning, and then the name ends with an n. So everything that ends with an n will be found. Let's see what happens. And yeah, we have our Norman, John, and the bands all ends with an n at the end. So we see here 5 characters in front, which is fine for the percentage, or if it's just 2 as well. Another thing we can filter for are lists of values, and this is what we do with the in keyword. You can say first name in, and now we just want the ones who are called Ben or Norman. So we expect that the John will now be gone if I run this query. And yep, that's happened. So now it's only the Bens and the Normans. In our dataset, we also have the value null. Null is a special value inside SQL, and it means it's an unknown value. And it also needs some special treatment. If I try to do the following, where manager ID equals to null, and you see there is one row where the manager ID is null, but if I run this, I get 0 rows back. That is because in SQL you cannot ask if something is equal to unknown, equal to null. And if you want to query or compare with null, you always have to say is null, if something is unknown, so to say. And if I run this, there we get it, the Ben who has no manager. All right, now we have already our base vocabulary in SQL, and we can start to get analytical. We can start to derive real insights from the database. Let's, for example, say we want to see what is the maximum salary of our employees. Let's remove all this in front here, and we just want to see what is the maximum salary. It's an aggregation, and we will remove all other stuff. So just give me the maximum of salary. And there we have 100,000. It's the one from the Ben with a high salary. As you might expect, we can also say, give me the minimum of the salary, or give me the average salary. Running this, and we see, okay, maximum is 100,000, minimum is 1,000, and average is 63,200. Another thing that we can do is count. We can say, count me the number of rows, which is the special case again for the asterisk, so over all columns. Count me all the rows. And another thing we can do is a combination of count and distinct. Let's say we count the distinct number of first names. As we know, we have 2 Bens, and when we do a count distinct of only the first names, we expect a 4 because one of them is duplicated. And yep, that's what we get. We have 5 rows, and 4 of them have individual first names. Count distinct, very powerful functions as well. Okay, these were aggregations, and we can do aggregations also over groups. We group our data, so we have some buckets of data, and then we can do calculations on those individual groups. And to have that, we first need to define a group. And let's say we want to group our data by our department. So we want to see now those aggregations that we have defined here, but broken down by department. And once I put it down here, I can also put it here as a column that we want to see. If I execute this, now it gets really interesting. We have one employee that has no department attached. He's the one with the 1,000 salary. And yeah, not very interesting, this row. But from the HR, we have 2 people working there. And the maximum salary of the employees is 70,000. The minimum is 65,000. And obviously, if it's just 2, the average is then 67,500. And the same for the IT. All right. That was already the fast rundown of SQL queries, and we arrived at the point where you can write some analytical queries. I hope you enjoyed this video. In case this was now all a little bit fast-paced for you and you could not remember the syntax, down in the description I put a link for you where you can download for free an SQL cheat sheet where you can see those queries in a PDF form, and you can then use it as a reference.